My name is David Mason from IOTA, Southeast Water here in Melbourne, Australia. I'll explain a little bit more about who and where we fit in. But I want to spend the next 15 minutes to share some insights from Southeast Water and their digital utility program, which is delivering network leak detection at scale. I'll cover some of the technical details around this new and exciting technology innovation that was developed at Southeast Water, and touch on some of the key outcomes so far as we start our mass rollout of our advanced AMI water metering to 1 million meters over the next 5 years. But first, as I said, a little bit about Southeast Water and IOTA. So Southeast Water is a state-owned government utility, and we're one of 3 water retailers in the southeast part of Melbourne. We service 1.8 million people across about 750,000 households. We buy our water off the bulk water supplier, Melbourne Water, who manage the centralised supply, including storage and production plants such as Desal. Now, IOTA is a fully owned subsidiary of Southeast Water and was set up back in 2014 to commercialise some of the technology developed by Southeast Water when they couldn't find solutions in the market. And we deliver our purpose by incubating and commercialising and then looking for partners globally to scale out this portfolio of technologies. And as with this vibration sensor, the IP, which is developed and then proven at Southeast Water. Hence, we're in a pretty unique position to understand the challenges of technology adoption in the water sector and help accelerate the innovation adoption to deliver real impact in our communities and beyond. So let's get into some of the detail of why Southeast Water developed this new approach to network leak detection. From an Australian perspective, I'm pretty sure, I suspect, will be common to your parts of the US. We went through one of the worst droughts back in 2009. Our demand is increasing as we grow in population, but our supply is very much dependent on rainfall. And over the past 30 years, this has dropped markedly, as well as being more vulnerable to climate change. So our big challenge we face is demand rising and supply dropping. Ordinarily, we lose on average about 20% of our storage annually just due to demand. We already have a large desal plant, and we're in the process and planning to build another to secure our supply into the future. But that's not really a great outcome for our customers, as this has a direct and immediate impact on bills, and it's not good for the environment. So the longer we can hold off the augmentation, the better. So we're aggressively seeking demand reduction wherever possible, both on customer side leaks, but also on network leaks. And we're aggressively going after that through this new cellular-based AMI technology approach. So reducing non-revenue water is key for us. I think we're all aware of the impacts from non-revenue water. It's financially costly. I think your non-revenue water rate across the nation is similar to what we have here in Australia, at around 14 to 18%, which translates into trillions of gallons of water lost each year. And in addition, it causes a lot of unplanned outages and disruptions to our customers, especially if a small leak goes unnoticed and develops into a burst, as shown in this picture. So how has Southeast Water gone about addressing this challenge through new technology? So there's many ways of identifying network leaks, and I'm sure a lot of you have deployed DMAs, and some of you may even be using people walking around the network with listening sticks. Now, they're expensive to deploy and maintain and don't really provide near real-time data about your water network. Southeast Water has also used many of those traditional network leak detection approaches that are a point in time to identify leaks, but they also wanted to have a more real-time approach to network leaks. So they imagined a world where we could eliminate most of these types of network leaks through an always-on leak detection system across our old pipe network. All of a sudden, our dark network has become intelligent, sending leak data to the cloud every day, 365 days a year. And the really key part, at a small incremental cost to our existing AMI smart metering rollout. So this miniature vibration sensor that you can see in the right-hand side there, that's actually a smart meter, or what we call here in Australia a digital meter. It's opened up, and the actual vibration sensor, which we've been able to miniaturize, sits actually on the brass pipe and listens for vibrations which are being transferred across metal and or plastic pipes, and are picked up then by this very sensitive vibration sensor. Now, this sensor uses a very small part of the meter battery to power it, and over a life of a digital meter, which is anywhere between 12 and 15 years, it takes about 3 to 6 months of battery life from the meter. So how does it actually work? So the actual SOTO sensor itself takes several vibration samples during a set period at night, which reduces interference from other sources of vibration. Now, the sensor detects a vibration within a set frequency range that reflects optimal detection of water leaks. 9 samples of vibration data are captured, 1 sample every 15 minutes between 12 and 2 a.m. Now, the device itself has a built-in processor, so it calculates the medium peak vibration from the set of frequency waves, that waveforms, and provides a single vibration intensity score. And this score indicates the presence and magnitude of a network leak. Now, this data is then sent as part of the daily meter payload up to the cloud platform for analysis and analytics. Here's a great example of a leak in South East Water's network that initially went undetected, but was picked up by SOTO very early on in its life cycle, and it was observed over time before they went and sent a crew out to fix it. Now, the vibration intensity score, or what we call the area under the curve value, it's actually used by a network leak specialist, or in the future, advanced analytics to triangulate the location of where the actual leak is. It can take multiple readings from adjoining meters. As you can see, the leak was actually picked up by multiple meters, each with the vibration sensor. So how did South East Water go about actually implementing this approach, and did the business case for this actually stack up? When it came to South East Water's overall business case to roll out this new innovative solution to address non-revenue water, we worked with Jacobs to help, I guess, validate some of the key assumptions, and in supporting the positive business case to roll this out at scale. And it was confirmed it was only a small incremental cost on top of what was already planned in our deployment of up to 1 million digital meters over the next 5 years. So just how much water was saved, or that we predict to save once we roll out at scale. As I said, with the support of Jacobs, we validated that at least 1% reduction in non-revenue water leaks was economically viable. So considering both the cost of the sensor as an incremental cost, but also taking into consideration the cost to fix the leaks, we were very confident that on a yearly basis, we can save up to 420 million gallons of water each year. So not only has SOTO been able to pinpoint previously undetected leaks, it's also been able for us to detect existing leaks earlier. So that's a massive water saving, which has really translated into a positive business case for our overall deployment of our AMI smart meter network. As mentioned earlier, we're a water retailer. We work with the other retailers and our bulk water wholesaler to derive what we call a long-run marginal cost of water. It's critical to derive the true cost of water that includes all the implied costs of augmentation of assets. And once that was developed, it made this digital metering program economically viable. But the original business case without non-revenue water and SODO included still didn't stack up. So we needed to go back to the drawing board and look at other smart technologies that we could also include in our smart meter rollout, which is really how SODO came about as well. We needed to think, how could we deliver more value from this AMI digital metering rollout, which when we did include SODO, it delivered almost a $33 million return and made the overall business case stack up. So that's what we've used in our digital metering business case for the decision to scale out our overall AMI program from currently 100,000 meters to 1 million meters over the next 5 years. 60% of those million meters, so 600,000, will include this new vibration sensor to really identify leaks in our old and leaky parts of the network. So as we scale out, as I said, to 1 million meters over the next 5 years, we're also worked on the algorithm to remove false positives. We've got 2 years of data that we've now put into an analytics AI program to help weed out false positives. So rather than sending out crews when there's not really a leak, we've now started moving from a test and learn phase into normal operations. And the key sort of characteristics of that in terms of our future state is that these leaks will be automatically identified, verified, and then categorized through this AI platform each day. And then we'll look to batch up those leaks into our workforce and workflow system, both based on proximity and urgency. So that will be a massive way of how we can reduce costs to fix leaks, so that initially that classification will enable us to send crews out, firstly to excavate the leaks en masse in a particular area, and then after that send out again another specialist crew that can repair the leak, thus optimizing our overall cost of leak repair. So not only do we get a massive benefit in water saving, we are also looking now to get a massive saving in our operational costs to fix leaks. So just in closing, as part of IOTA's commercialization role, we're working with many of the global metering companies already to license this SODO IP. So if you're thinking about upgrading your existing AMI metering fleet, then adding in SODO to address non-revenue water is pretty easy by simply selecting a meter that already has SODO in it. And it comes at a small incremental cost. You own the meter, the sensor, and importantly, the data. Alternatively, happy to have a chat afterwards, and we can talk about embarking on a small pilot and explore the right meter manufacturer that could support you in your area. So at that point, I'll close and open up for questions.